Okay, on to concept number 18, fundamental theorem of calculus. If you want more practice at the old integral stuff, there's thousands of problems you can work on. I'm not interested in reviewing that part of it right now. I want to talk about big ideas. So we watched a fun video. Remember, the integral from A to the B said, hey, is the integral of B less the integral of A? The integral of A to the B said, hey, if you want to look up TI-83 wrap, that's where that came from. That's the first fundamental theorem of calculus that we talked about. The integral is the area under the curve. So if you're above the x-axis, it's a positive number. If it's below, it's a negative number. If you're going opposite direction, so the integral from A to B of f is the opposite of the integral from B to A of f. So if you go the other direction, it changes the sign. Important things to know: if you're given information in the wrong direction, you can change it back to get the right answer. Those are definite integrals. Please practice those. Then check them on your calculator. Remember, on your calculator, it's function int. This is a good practice problem. I'll put a solution on later. Find the value of x and k divides the area between the x-axis, x equals 4. Good big question shows up a lot, dividing area in half. Properties of definite integrals. You can break them up into sums, just like derivatives. You can break them up. So this could be the integral from 2 to 5 of g plus the integral of 2 to 5 of 4. And so then this, you know what g is, and you could find this. It's a rectangle that's 3 by 4. You can put the constant out in front. And then we have our normal graph shifts, left to, right to, whatever. It kind of gets into the chain rule. I'm not going to go there right now. Average value of a function. I'm just going to skip right to this part. Skip that mean value theorem for integrals. Average value of a function. Take your integral, and the way I think about this is you're dividing by the width. So if you know the total area and you divide by the width, you get the average height. That's what we're saying. So whenever you see average value or average, you have to consider this function. If you know a function where they give you the velocity and they ask you for the average velocity, you're going to use this. If you know the function for displacement and they ask you for average velocity, you're going to use slope formula, because the mean value theorem is a similar connection with slope as with integrals here. Okay, we keep going on to number 21 on here. Second FTC, the derivative of the integral from the a to the x f of t dt equals f of x. And then you get this little thing times dx. That's the only thing you got to be careful of. So the shortcut is the derivative of the integral, as long as you're going from a constant a to a variable x, the derivative of the integral is f of x. Well, it makes sense. It's the if they're inverses of each other, they're inverse operations. The thing you got to be careful of again is this dx. This is right here. This is important. So in this case, my dx would be 1. But in a problem like this one, it's super small. You can't see that's x cubed. After you plug in your x cubed for t, sloppy. After you plug that in, on the outside here, you'd have to multiply by 3x squared. And basically, that just helps you with the chain rule. If you ever get stuck, you could actually integrate and do the double substitution. The reason the second FTC works, and the reason why we have the derivative of the integral that works, is because if you actually did this and you did f of b minus f of a, or in this case f of x minus f of a, you take the derivative of f of a, it's 0, it's gone. I strongly recommend you watch the integral as accumulators set of videos to review some of that and how it plays out with graphs. Okay, keep going here. Functions defined as integrals. Again, I'm going to suggest you go to the integrals as accumulators. And work through a whole bunch of those problems, or just at least watch the video on how to do that. That was something we did not get to as much first trimester. The thing to know in the shortcut is that they're often going to give you the graph of the derivative, and you're going to integrate to see what happens. So the accumulator means like the basics are where you started, which is whatever your condition is, plus the integral from wherever you're at. Sometimes you start at 0, sometimes you start at 5. The integral of the derivative. So the derivative or the rate, this is the total change. So where you start plus the total change is where you end up. We did it a lot with position, your initial position, plus the integral tells you where you're at. If this is an absolute value, then it tells you how much you covered. If it's not an absolute value, it tells you where you're at. But a lot of extra practice there. Problems. Area between curves. Be careful when dealing with area, it says. Integral of top minus bottom. The time to be careful, I would say, and when you do the multiple choice test, you will see that. The time to be careful is understanding that top minus bottom could change. So if we're finding the area from here to here and from here to here, you can't just do the whole interval. You still got to do top minus bottom. The pink, you'd have to do the pink minus the pencil, and then you'd have to switch it around, the pencil minus the pink. So you'd have to have two different intervals. Also, going right to left, if the functions are in terms of y instead of in terms of x, you're going right to left. There's some other problems there. Again, I'll work through some of those for you later on. Slabs, we didn't call those slabs. We called them cross sections, but these were your formulas for volume. We spent a good amount of time on that. You just need to find what we call a side. We called that a side. In other words, the distance across, because then whatever shape they're telling you, that's going to pop up off of there. And so we're adding up all those shapes. They're 3D. They're infinitesimally small. Their width is going to be the dx. So like if these were all squares, it would be the integral from a to b of our side squared. That gets you the area of this, and then times the width of dx. That gets you volume. So really a bunch of square prisms we're adding up. Sometimes they give you an equation. They might say the slices or the cross sections are the sine function with some weird complication. But we did a lot of volume ones. You may want to review, just making sure you know the difference between the slabs and the rotation.